Okay, good afternoon, ladies and gentlemen. This is Professor David J. De Los Reyes. Uh, what I will be discussing this afternoon will be the setup of my solar equipment. On this side here, I got my first batch of solar panels. Okay. The wiring is underneath and it came out here. So this one goes to the gazebo. Okay. Then later on, I will merge this wiring here to the other panel, so they will go inside the house. Okay, I will show you the other solar panels. The other solar panels are actually this one here. Okay. The wiring is underneath. The wiring is underneath. And these three solar panels are actually connected in parallel. The converged wiring is actually this one here. It goes up on the gazebo. Okay, we'll go now inside the gazebo. Inside the gazebo, the first batch of wiring, this is the first batch of wiring coming from the other side. This was on the second group of panels, and I merged the wiring here. So there will be two lines going inside the house, and that's actually the wiring. That's actually the wiring. So there will be two group of solar panels with two wires going inside the house, and that wiring is actually here. You see, the first one. The first group of solar panels, the second one, the second group of solar panels. It goes inside the house. Okay. It goes inside the house. It goes in here. Two lines from the first group of solar panel and the first group and second group. I will now go inside the house. So inside the house, the two lines coming from outside are actually this one here. This came from the first group of solar panel. This one from the first group of solar panel. And I will show you the connection. Okay. The merged connection will be this one here. Okay. So I now make the connection of the two different lines, positive, negative and negative. Then they go to this solar charge controller. This is the plus terminal. There are two red lines here because I connected the two group of lines in parallel. And the ground portion is actually this one here. This one. So I place what they call this a circuit breaker between the solar panels and the charge controller. Okay. The purpose of this circuit breaker is that any short circuit on the charge controller, okay, there will be large current, and if that happens, this will pop out. Just in case there is a short circuit on the solar charge controller. I will switch on this one. Okay, it's on now. Okay. And right now, the input voltage is actually 11 volts. No, 13 volts. 11. No, the voltage is 12.9. Coming from the two solar panels which are connected in parallel, and the total current they are giving now is actually 11 amperes. Okay, This is the icon for the battery that is being, what you call this, charged for the meantime. That blue thing is the icon for the solar panels. They are alive. And for this red one here, meaning to say this solar charge controller is alive. So right now, the total current given by the solar panels is 11 amperes. And the voltage is 13 or 12.9. So the output terminal will be this one here. This is the one coming from the solar panels. This is the output of the solar charge controller. And this wire here, there's a passive line. It goes to the passive terminal of the battery. The black thing here is the negative terminal. So right now, the solar panels actually is giving voltage. It passes through the solar charge controller, and the output of the solar charge controller is actually this one here. And that voltage is now what you call this, charging this 200 ampere hour battery. This 200 ampere hour battery is actually connected in parallel. The positive and the passive are connected. Negative and negative is connected. So if I connect the plus negative terminal here coming from the solar charge controller, and so with the positive one, right now these two batteries are being charged. The output terminal of these batteries are actually this line here and this line, and this goes back to the back of the solar inverter. As you can see it, this one came from the negative terminal of the two batteries. This one came from the positive terminal of the batteries. So the power supply of this inverter actually came from the batteries. So right now, the solar inverter is alive. Okay? It is switched on now. And actually, the load of this one is this one here, and that load is actually this big refrigerator here. So this big refrigerator get its power from the solar inverter, and as you can see it, I will try to open this one. It's working, right? So that big rep is now being powered by the inverter for the whole day, as long as the sun is out there, which is very hot. Okay, so this is the output of the solar inverter. Okay. Right now, the solar inverter is being powered by the two solar batteries, and these two solar batteries is being, what they call this, charged by the solar panels coming from outside through the solar charge controller. Okay, I will repeat it. The output voltage of the solar panels is 13.7 volts, and I will try to toggle this one. We could see the total current they are giving to the what you call this, batteries. Right now, it seems the batteries are now fully charged, and they're only taking 3.1 amperes coming from the solar panels. So from this, we could see the current given by the solar panels. And if we try to toggle it, that's the input voltage going in, 13.7 volts. So the voltage charging the two batteries is 13.7 volts, and right now they are giving, or they are taking 3.3 amperes, because it seems the batteries are now fully charged. Okay. This is a 2400 inverter sine wave. So actually, we couldn't plug in here. If we try to use our low, what you call this big televisions, we could use this one because the output of this one is actually alternating current sine wave. It's not a square wave, it's sine wave. So actually, we could use this one to power up our so-called entertainment center. But right now, the load is just the refrigerator, and as long as the sun is shining outside, the power that goes to the what you call this refrigerator is actually free. Okay. Oh, that is just the setup. It's just a simple one. For the protection of the battery, just in case there's a short circuit on the inverter, actually I put a circuit breaker between the battery and the what you call this inverter. If a short circuit occurs on the inverter, there should be a big circulating current. It's in the range 100 amperes. So if that happens, there will be a catastrophic thing that will happen. So to prevent that one, I put a 100 ampere circuit breaker here. And to show you that this is working, I will try to pop out this one. If there is a short, that will pop out. So right now, the what you call this, the inverter is dead. Right? I could pop in this one. I pop it in, and again the inverter is alive. So the main purpose of that circuit breaker between the battery and the inverter is to protect any large current just in case there will be a short circuit that will occur in the inverter. Because if there is a short circuit that will occur in the inverter, okay, this will pop out. Okay, it will pop out like that to protect or to prevent that big circulating current if there is a short circuit on the inverter. But since there is nothing, actually I could have pushed this one in. Okay, the circuit breaker is on, so the inverter again is alive. Okay, so there are two protections here. The protection between the inverter and the battery is actually this one here. And the other protection is that it's a circuit breaker, okay, between the solar charge controller and the solar panels. The use of this one here, just in case this will short circuit, okay, this will pop out. Okay, and if there is no short circuit, we could close this one. And again, the solar charge controller is alive, meaning the voltage and current coming from the solar panels is actually active. So this is the protection between the solar panel and the solar charge controller. And this is the second protection between the battery and the inverter. So this is what I call this a very safe construction or setup of a solar panel equipment. All the protections are here actually to prevent any fire that will occur. Okay, good afternoon from Los Angeles. This is Professor David J. Delusri.